have to see where the inside is going when x approaches infinity, and this is natural log x, so it's going to infinity. So this piece is going to infinity. Now I have to remember the graph of arctangent, and that's why I insisted that my students remember the graph of arctangent, because it has horizontal asymptotes at pi over 2 and negative pi over 2. So now I'm really interested in arctangent as x approaches infinity, as the inside approaches infinity. So as the argument of arctangent approaches infinity, the function values get closer and closer to pi over 2. So this is really not a situation on L'Hopital's rule or indeterminate cases or anything. It's just a situation of plugging in.
Can we do the next one? B, part B for number 2.
Can you tell me what it is?
Yeah, definitely.
I'm logged out again. I'm not sure what's happening. Maybe my system is, but I can look at the other computer. But on my own here, I'm just logged out again.
That's fine.
But so I can pull it up on my in my files, so it's fine.
Okay. So it's the limit as x approaches 1 of the I'm sorry, 2x minus 2 over the absolute value of x minus 1.
Good. So here we have to go step by step, and we have to start with the absolute value of x minus 1. That has two options. One option is x minus 1, when x minus 1 is greater than or equal to 0, which changes into x greater than or equal to 1. And if that one is greater than or equal to 1, this one must be less than 1. And that is negative x plus 1. So now the function 2x minus 1, I factor the numerator, and the denominator is the absolute value of x minus 1, will have two options because the denominator has two options. So one for strictly greater than 1, not equal to 1, and the other one for less than 1, and the reason is the denominator now cannot be 0. So I cannot have the equal symbol here. So when this is x minus 1, I have x minus 1 over x minus 1, which is 2. And when the denominator is negative x minus 1, then I have negative 2. So since x approaches 1 from either side, I have to determine both limits. But obviously the limit of the function as x approaches 1 from the left is 2, and limit from the function as x approaches 1 from the right, this was negative 2, so 1 from the right is 2. So then now, only now I can write dne here. But I have to simplify the function, and I have to determine both limits because the limit is from either side. And when the limit is from either side, I have to determine both sides. Because it could be that both sides are infinity, for example, and then I cannot write dne. It could be that both sides are negative infinity, and again, I cannot write dne.
Thank you.
Thank you.
I mean, unless someone else has a different idea, I think it might actually be beneficial to go through the practice final exam, because I don't think anybody else is going to have anything, unless someone has something specific they want to bring up, which maybe this will like jog someone's memory and bring up a problem they wanted to go over, but maybe just going over the final exam might be a good idea. Like problem by problem. I know it sounds like I don't know what else to do.
That's fine. As I said, today and Wednesday are your days. You tell me what you want me to do, and that's what I'm going to do. So let's look.
I agree.
Perfect. I just don't want to but I do what helps you. I don't want to just go over problem without you having any input, because I think that you're just watching again me do things. But if that helps, I'll do that. So let me open. Again, I'm logged out. I don't know why on this computer. At least can you point out what problem for me to continue with? Is something that you may not need, or just point out what I should continue, and I'll do that.
Okay, I mean,
Anything.
I'm looking through it now, and
Sure.
it's. I mean, for me personally, like I don't want you to sit here and like do the final exam in front of us, because, like you said, I don't really think that's beneficial. But maybe if it was sort of like how you go over it in class and ask us for input as you go along.
Yes, absolutely. So just indicate which problem you want me to start with. Yes, that's exactly what I wanted to do.
Okay, so maybe we could just start from number 1.
Okay, very good. So in number 1, we have a function. All these problems come from previous tests. Find the equation of the tangent line to the graph when f of x equals 3. So there is a point when x equals 3, so I'm not given the y value. So I'll plug it in. 3 times 3 is 9 plus 2 is 11 divided by 1 is 11. So I'm getting that ready. And I know that I have y minus y1 equals the slope times x minus x1, right? And this is 3 comma 11. But what I don't have is the slope. Is this okay so far? And now the question is, how do I determine the slope? So how do I get the slope at 3? Well, the slope at 3 is f prime of 3. So find the derivative of the function using the limit of the difference quotient. So they're not asking us to determine using the definition, using the differentiation rules, but the definition. So, and then I have to find f prime of 3 to replace m by. So if that's the case, then I have the limit as age approaches 0 from f of x plus age minus f of x divided by h. So this is the definition of the derivative as the limit of the difference quotient. The limit of the difference quotient. So now I have to determine this. I plug in x plus h, so I get 3x plus 3h plus 2 over x plus h minus 2, and then minus 3x plus 2 over x minus 2 divided by h. Now, if you remember, 2 things have to happen here. All terms without h must go away from the numerator. And eventually the h in the denominator has to go away. What is our next step?
Get similar bases.
We need to find the least common. I know what you mean. The least common denominator. And what is the least common denominator?
X minus 2 and X plus H minus 2.
Yes, it must be the product of those two. Excellent, thank you. So this is X minus 2, X plus H minus 2. But now I cannot, remember we cannot copy the numerators. We have to multiply the top of the first one by X minus 2 and the top of the second one by X plus H minus 2. And I'm expecting all terms without H to go away. Maybe some terms with H, but I don't care. I care about those terms without H. So X times 3X, 3X squared, X times 3H, 3XH, X times 2, 2X. And watch me run out of room, of course. Negative 6X, negative 6H, and minus 4. And minus, I will continue here, I'm sorry. There are no two minuses, but I'm just saying that there is something that follows. Negative 3x times x, negative 3x squared. I don't need to put it again. Sorry. It's very clear, it's there already. And then negative 3xh, and then positive 6x, and minus 2x, and minus 2h, and plus 4. Okay, so these two go away. These two go away. These two go away. These two go away. And these two go away. So the numerator is left is negative 8h. And then I have to flip the denominator. So the next step, limit as h approaches 0. The numerator is negative 8h divided by all that as x minus 2, x plus h minus 2 times 1 over h. And that's the second thing that must happen. And now when I plug in 0 for h, I get negative 8 over x minus 2 squared. And then I plug in negative 3. No, it was 3. So 3 minus 2 is 1. 1 squared is 1. So this is negative 8. So coming back to my equation, y minus 11 equals negative 8 and x minus 3. Before I continue and solve for y, I want to differentiate using differentiation rules to make sure that I get this. Because now I have that tool, which I didn't have in chapter 1. I'm sorry, of course, chapter 2. So f prime of x, the top function prime is 3 times the denominator minus 3x plus 2 in parentheses times the denominator prime, which is 1. So this is 3x minus 6 minus 3x minus 2. Indeed, I get negative 8 over x minus 2 squared. So that's correct. And now I have to solve for y. So y equals negative 8x. And this is plus 24. And then plus 11. So then y equals negative 8x plus 35. And this is the equation of the line that is tangent to the graph at 3, 11. This is just routine now, right? This part. I'm hoping you're going to review the other tests between now and Monday as well. That's what I've been kindly asking you to redo all tests every weekend. So you have everything fresh in your memory. Any questions on this? By the way, is the homework finished for Saturday? Okay, so next question. What do we continue with? We did 2A and 2B. Yes, Sean, go ahead.
I was going to say, I have one that's also from the final exam.
Yes, yes, please.
It's from section, I don't know. It just says, use differentials to estimate sine 46 degrees.
Yeah, so remember this is f of x plus f prime of x dx. If I identify f of x, if I identify x, if I identify dx, and then I find f prime, all I have to do is put them in here. So let's identify, first of all, the function.
It's sine?
Of course. Yes, that's all we have. We have sine x. So then I know sine prime is cosine. Okay, let's identify x.
46.
And careful. We don't know anything about 46.
Oh, it's isn't it like the closest that we can get in degrees or something?
But that would be dx.
I mean, I can't remember. Radians?
No, but we don't know anything about 46. What is the closest that we know everything about?
45.
That's it. And what about dx then?
That would be, is that the pi over 4?
We are talking about this yet. We haven't decided anything else, right? So if x is 45, then what is dx? What is the error from 45 when we get 46?
1?
Yes, which has to be changed into radians. So if I had here 45, I would have put the answer to square root of 2 over 2 and I was done. I would be done by now. But this is 46. So there is a minor error from 45 that I know everything about. And the minor error is 1 degree, which in radians is pi over 180. So now I have everything. So this is my dx, which is pi over 180. I have f prime, which will be cosine of 45. And I have f of x, which will be sine 45. So this is sine 45 degrees. And this is plus cosine 45 degrees. This is this, plus times 1 degree, which has to be pi over 180. See, inside a function, a trig function, if I put radians or degrees, the answer will be the same. It doesn't matter. But if it's outside, this number is 1 degree, but it's outside of a trig function, it has to be in radians. So then I know that this is the square root of 2 over 2, and this is the square root of 2 over 2, and this is pi over 180. So the exact answer is this, 180 plus pi over 180. So what I did, I factored out the square root of 2 over 2. And then I got 1 plus pi over 80, which is that. So simplified is the square root of 2, 180 plus pi over 360. Now, if I want to approximate, this I can approximate. Even by hand, I can do it. It will take me a while, but I can do it. But this I can't. So I have the square root of 2. And then multiply by 180 plus pi. Close the parenthesis, and divide by 360. Now, this is a product of 2 factors. You don't need parentheses, but if we had a product of 2 factors in the denominator, we would have had to put parentheses. So when I press enter, I get 0.71944. Now, if you want to check, you can plug in sine of 46 degrees, but make sure that the mode is in degree mode now. 0.719339. It's a perfect approximation, I would say. Very good question. Is this clear?
Yes, it is. Thank you.
Thank you. So remember how we get this concept, that the exact change in y is approximately the differential of y. And now we have to put the formulas for both. This formula, as we know, is f prime of x dx. This formula is f of x plus dx minus f of x. And we get this to the other side and we get that. So that is the starting point. I want you to remember this idea, less than the formula per se for the future, because you're going to use it. You're going to use it in Taylor series and others, when you will replace this by the equal symbol. So pretty similar.